The Internet, a global network weaving invisible threads of information around our planet. Every second, petabytes of data rush through it. Emails, videos, social media messages, financial transactions, scientific research, cat memes. Literally everything we create and consume digitally. It's a colossal, continuous flow, like a river surging into an ocean of knowledge. Now, imagine an incredible challenge. What if we tried to funnel all of today's internet traffic from 1 second through the most powerful supercomputer currently in existence? What would happen to that computer? Could it even handle such a volume of information? And what consequences would this have for us and for information itself? Prepare yourselves, because we're diving into a world of incredible speeds, astonishing data volumes, and the absolute limits of computational power. First, let's try to gauge the scale of this task. Just how much information flows through the internet in 1 second? The exact figures are constantly changing and growing, but by the most conservative estimates, it's hundreds of terabytes, if not petabytes, of data per second. 1 petabyte is a quadrillion bytes, or 1,000 terabytes. Imagine a library containing billions of books, and all of it has to rush through a single point in an instant. It's a flow comparable to an entire ocean of data trying to force its way through a narrow bottleneck. Now, let's talk about the most powerful supercomputer currently in existence. As of our conversation, the leader in this computational race is, for example, Frontier, located at the Oak Ridge National Laboratory in the USA. Its performance is measured in exaflops. That's a quintillion floating point operations per second. That's an incredibly vast number. Imagine a billion mathematical calculations performed in just 1 second. But is that enough power to funnel all internet traffic? Most likely no. Supercomputers are optimized for performing complex scientific calculations, climate modeling, nuclear simulations, and the like. They are not designed to process a raw, unstructured stream of data coming from all corners of the network simultaneously. It's like trying to use a racing car to transport all the goods from a massive shopping mall at once. So what would happen if we actually tried to feed this colossal stream of information to our supercomputer? The first and most obvious outcome would be overload. Imagine a water pipe through which you try to push a flow of water thousands of times greater than its capacity. The pipe would simply burst. Similarly, the data transfer channels and internal architecture of the supercomputer would instantly be overwhelmed. Memory buffers would overflow, processors would drown in an attempt to handle the incoming stream, and the system would most likely simply freeze or crash. But let's assume the impossible. Somehow, we managed to squeeze all this traffic into the computer. The next problem would be processing speed. Even with its immense computational power, the supercomputer would require an enormous amount of time to analyze and process such a volume of diverse information. After all, it's not just numbers. It's text, images, video, audio, executable code, all in the multitude of formats and protocols. The supercomputer would be forced to dissect each data packet, determine its type, recipient, content, and all of this would need to happen in that very single second, which is physically impossible with current technology. Let's consider one of the key aspects: physical limitations. Data transfer and processing require energy. Moving such a huge amount of data inside the computer and between its components would generate an enormous amount of heat. Even the most advanced cooling systems simply wouldn't be able to cope with such a heat flux. Overheating would occur, which at best would lead to an emergency shutdown and at worst to physical damage to the supercomputer's electronic components. The microscopic transistors that form the basis of processors and memory would simply melt under the tremendous temperature. Furthermore, there's a fundamental limit to the speed of information transfer, determined by the speed of light. Even if we could create ideal data transfer channels within the computer, information cannot travel faster than this speed. Given the physical dimensions of supercomputers, even data transfer between different blocks would take time that could be comparable to or even exceed that single second. But let's go further and hypothesize. Suppose we created a hypothetical supercomputer with infinite computational power, instantaneous data transfer speeds, and a perfect cooling system. What would happen to the information then? Even in this scenario, the problem of structuring and analysis would arise. All internet traffic is a chaotic stream of diverse data. To extract any meaning from it, a colossal effort would be required to organize, index, and analyze this information. Modern search engines dedicate enormous resources and time to constantly scanning and cataloging web pages and other data. Attempting to do this instantly with the entire volume of internet traffic in 1 second seems like an utterly insurmountable task. Moreover, some information on the internet is redundant, outdated, or simply meaningless. Funneling all this digital junk through a hypothetical supercomputer would bring no benefit, only making it harder to analyze truly valuable data. And finally, let's consider the consequences. Even if we miraculously managed to process all internet traffic in 1 second, what would that achieve? Instantly receiving all available information could lead to an information collapse. The human brain is simply incapable of perceiving and processing such a vast amount of data. It's like having all the books in the world poured on you at once. You would simply drown in that flood of information. Furthermore, such a concentration of all information in one place would make this supercomputer an incredibly vulnerable target for cyber attacks. Imagine all of humanity's digital life centered in one machine. Its failure or falling under malicious control would lead to catastrophic consequences. In summary, attempting to funnel all of today's internet traffic from 1 second through the most powerful supercomputer currently in existence is a task far beyond our current technological capabilities. The supercomputer would most likely instantly overload, overheat, and crash, unable to handle the colossal volume and speed of incoming data. Even a hypothetical super-powerful computer would face fundamental limitations in information transfer speed, and analyzing such a chaotic stream of data would remain an insurmountable challenge. And even if we miraculously achieved it, the consequences could be catastrophic, leading to an information collapse and creating an incredibly vulnerable single point of failure for all digital civilization. So while the idea sounds intriguing, the reality is that the internet is a distributed, dynamic system, and trying to compress it into 1 second through one computer is like trying to scoop out the ocean with a thimble. It's simply impossible. Thank you for watching. If this video made you think about the incredible scale of data, please give it a like. And to not miss new fascinating stories and what-if scenarios, be sure to subscribe to the channel.